The first thing that we'll end up talking about is what are the reasons that we have that you need to upgrade from SQL 2008. And of course, there's dangers associated with staying with 2008, but there's great amounts of benefits with upgrading from 2008 to the newer versions of SQL Server. We're going to actually talk about both of those. We're going to try to help you choose the right version of SQL Server, and also you need to choose which edition of SQL Server do you need to go to. We're going to talk about the Upgrade Advisor that's built into SQL 2012 and 2014, and then the newer Data Migration Assistant that's available in SQL 2016. And then last but not least, we're actually going to talk about some of the upgrade methods that you need to use to go from the older versions to the newer versions. Maybe it's just an in-place upgrade. Maybe it's a single server upgrade. Maybe you were able to get do a hardware upgrade and do a two-server upgrade. But we're going to talk about some of those different methods to actually upgrade from the older version to the newest versions. All right, so I mentioned it briefly, but what are the dangers of not upgrading your SQL Server? Okay, of course, SQL 2008, we know now that it's reaching the end of its extended end of life. And so on July 9th, 2019, we're no longer going to have support from Microsoft for the product. So what does that mean? Well, number one, you're not going to get your security updates and hotfixes needed to keep the software up to speed. So that's a big piece of protection that's going to be gone. So no more security updates, no more hotfixes. If one of the latest scams or attacks comes out, this software will no longer be upgraded, and you put your business at risk. So there's a lot of security exploits out there. If you don't get the proper updates and hotfixes, you had to take the chance of getting your data stolen. One of the businesses I worked with in the past, they were lax about putting updates on their servers. They did get behind, and they were attacked with a hijacked ransomware. And if they would have kept the hotfixes up to date, that would not have happened. So I don't want to see you get in the same boat as that customer that lapsed behind, and you don't want to put yourself in that situation for your business. Also, last but not least, you may fall out of compliance with industry regulations. So what does that mean? Maybe you're hosting a third-party application for your business on the server. When SQL 2008 is no longer supported, it's a high chance that third-party vendor may no longer support you as well, because you're not keeping up to the industry standards for their software. So you don't want to put yourself in that situation where you're no longer supported. That's, of course, like I said, I'm talking about the fears and dangers of upgrading and why you need to upgrade from 2008 because of the lack of support coming up. But I think that some of the main reasons you should upgrade from 2008 are actually the next slide, or the benefits that you'll actually have by upgrading, not just the fears. I know our businesses sometimes need to know what's going to happen to me if I don't upgrade. SQL 2008's been out for almost 10 full years, and it's been a very stable, very solid product. But that's going to change, and our businesses sometimes need to know some of the dangers and warnings so that way they can make proper decisions on what they need to do. But the next slide is probably the one I prefer because we're going to talk about the benefits that you're going to get by upgrading from SQL 2008 to one of the newer versions of SQL Server. All right, so like I mentioned, I've been dealing with SQL Server for about 20 years now. And the first point under my benefits is the performance increases you're going to be able to get by upgrading to one of the newer versions of SQL Server. Okay, so 20 years ago, I was working with SQL 6.5. Back then, a 1 terabyte database was a rarity. It was something you heard about. Yes, this business, hey, they have a 1 terabyte database, and it was kind of a big deal back then. In order to maintain or take care of that 1 terabyte database, it required a lot of special attention, some special configurations, some manual or special maintenance. You couldn't just run the wizard and couldn't do regular backups and couldn't do regular index rebuilds because it would take forever. It would bring the system down. You couldn't access your data. So it required a lot of special work back then. Well, each version of SQL Server that's come out since then has become more and more robust, and the engines are designed to handle larger and more data and more complex databases. So each version that's come out has been that much better. So nowadays, a 1 terabyte database is commonplace. Just about every business out there seems to have at least a 1 terabyte database or more data that they have to have taken care of. Well, SQL Server, and especially SQL Server 2016, can handle that much better. The maintenance runs faster, backups run faster, and you don't have to be or take care of it as specialized or as specific as we did those years ago. 2008 was a great product when it came out. 2012, 14, and 16 are definitely designed to handle your larger data and be able to perform at a much higher level. All righty, point number 2, you can eliminate your weekend analytics loads. Okay, so this is a point, of course, it's going to make all your BI architects excited. Okay, so SQL 2016, you won't have to wait for weekends or after hours to run those analytical workloads, the big numbers crunching that you end up having to do, all your after hours and weekend processing to derive your data for your reports and for your analytics. Now it can run at the same time during your business day, during your transactions. So you ask, how does that actually occur? You can do those simultaneously now by using the in-memory OLTP table settings and also the in-memory column store, as well as in 2016 now, the real-time operational analytics. So in SQL 2012, we introduced in-memory column store. In 2014, we introduced in-memory OLTP. And now in 2016, you have real-time operational analytics. You can actually have those number crunching processes running at the exact same time now as the transactions are occurring without hindering your production performance of your transactional databases. That's pretty amazing. Yes, it does require some work to get towards, but it's definitely a huge goal not to have those big downtime windows, after hours, weekend windows, where you can crunch all your data to be used during the business day. Now it can be done at the exact same time. All right, number 3, increased data security and increased encryption. All right, so in my warning tab that I had in the beginning, yes, we talked that you're not going to have your updates and hotfixes. So yes, of course, the new product is going to have all the updates and hotfixes that you need, but that's not what I'm talking about right here. SQL 2016 has new features inside it and new security models inside it that will actually greatly benefit you. So the first thing I want to talk about is a piece called Always Encrypted. So all of us have somewhere in our environment some type of sensitive data, and yes, we need to do something about it to make sure it stays safe. So those hackers that are out there, they try to get in, steal your data that's important to you or important to your business, and maybe you have social security numbers, maybe you have credit card numbers. Regardless of what it is, that sensitive data, what they end up doing, they try to figure out a point in your transaction where they bump in there and they sniff or they skim the packet and they try to actually steal it somewhere inside the transaction. So the end user, they put in their information, and after they hit go, somewhere along the stream is usually when it's stolen, and then they end up stealing that fresh data before it even gets a chance to get encrypted inside the database. All right, so now in SQL 2016, they've introduced what's called Always Encrypted, which means at the very beginning phase of the transaction, as soon as I type in my social security number, it's immediately encrypted. And so as soon as I hit go, as it transfers from my screen over to the database, it's already encrypted. So how do they manage this? It's actually done, it's like a handshake method between the SQL client and the back end, and now external keys. So there's external keys that are used. The data is encrypted from the very beginning across the whole process of the transaction, and the only people that can actually see the unencrypted data are those individuals on your network that have permission to use those keys, which are locked down, and then only they can actually see the unencrypted data, but the entire stream is already encrypted end to end. So if that hacker was able to somehow steal your database, it's already encrypted. If somehow they were able to jump in the middle of your transaction stream and skim off transactions, it's already encrypted and protected. So that's awesome. It's protected through all phases of the transaction, and it's not difficult to implement into your application. So they try to make it easy to plug in, easy to implement, and it's definitely much safer now. So that's the already encrypted or the always encrypted piece that's in SQL 2016. All right, they also have implemented row-level security in SQL Server, so which is another thing. You can lock down things now, even at the row level, not just the tables or not just the columns, but individual rows you can have protected now. All right, on top of that, we actually have dynamic data masking. So what's data masking? I can just tell you briefly. Still going back to the credit card window, you know how you put in the credit card information and maybe the first 12 numbers or whatever they are, they're hashed out and only a portion of it's visible. That's data masking. The masking that's normally done in applications require custom development. That's just the way it's always been up till now. So you required custom development, custom work. Now SQL Server can do dynamic data masking to where you can configure it and then your applications can just use it. So and what's also good about that too is you can determine which fields are masked and how the masking is going to occur, but it can actually make it to where if you need to have that SQL developer actually query and work on your production environment, you can configure the data masking and they won't be violating any of your compliance regulations. It's something that can automatically be masked and you don't have to worry about revealing the data and violating any of these compliance things. And it's easy to plug into your application. So it doesn't require a lot of custom development to be able to use. It's just a feature that you can implement, turn on, and utilize, and make it to where individuals that need to access your data can access your data without you violating things. Alrighty, fourth point, we have easier upgrades now by using the Data Migration Assistant. Okay, so we'll get into a little bit more detail on this coming up in the next couple of slides, but in the past we had the Upgrade Advisor that was good for SQL 2012 and 2014. Now they have a beefed up version called the Data Migration Assistant, and what's nice about this tool is that it actually can help you do upgrades and migrations, not just give you warnings or suggestions like, oh, you need to update your .NET version. You know, so the Upgrade Advisor would give you warnings and alerts that, hey, you're going to have a problem because of X. Yes, you'll still get warnings alerts with Data Migration Assistant, but it will actually help you do the migrations for you, and it'll help you even migrate logins and things. So we'll talk about that in a little bit more detail coming up in the presentation. All right. All right, now you have to make a decision, choosing the right version of SQL Server. So which version are you going to choose? Last week, they actually just released 2017. We've got some links included on some of the new features in 2017. You might want to take a look at that. What I usually do as a rule of thumb, when a new product comes out, usually most of the customers I deal with, you want to wait until probably the first service pack's released. After they've stabilized it, it's a good time to start thinking about it, but if you're thinking about 2017, you wait until everything's stabilized, probably service pack 1. But I'm going to talk a little bit more about 2016, 2014, and 2012 right now. I've included a link here at the very top here so you actually compare all the different versions, 2012, 2014, and 2016, but I've actually listed some of the things of the features that are included in 2016 that are not included in that comparison that Microsoft offers, okay? So I talked briefly about the always encrypted data. If you want that feature, it's definitely only available in 2016. What's nice about it also is not only does it work in the 2016 database, it also works in the cloud. It works with Azure. So that's a nice new feature, and it's available in 2016. I'm sure it's there in 2017 also, but we're talking basically about 2016 right now. The dynamic data masking that we mentioned briefly last slide, that's also a 2016 feature, not available in 2014 or 2012. This one is cool. I don't know how many, like I said, I've talked about all the different installs I've done with SQL Server or updates. Now they finally made it to where you can configure your TempDB during the installation wizard instead of having to do it afterwards. I don't know how many installs I've done where as soon as the install is complete, you got to go straight in, look at how many processors you have, try to figure out how many data files you need for TempDB, and then manually change it, configure it, stop and start your SQL Server, just another step to do. Now you can actually configure it during the wizard, during the install, with the regular configurations, and put the amount of TempDB files and the proper size that you need from the very start. So thank you, Microsoft, for doing that. It definitely will take one more step off our plates, and it's about time, I think, they actually added that to the configuration. Next point, Polybase. Now we have Polybase support inside SQL. So what does that mean? It means that you can actually use T-SQL to query your Hadoop and like your SQL Azure blob storage using regular SQL queries with regular relational joins. So how do you do that? After you have your SQL Server installed, you install Polybase. And after you have Polybase installed, it's just a simple spconfigure command. So it becomes a SQL configuration. You enable it inside SQL Server, reconfigure with override, and then after that point, you're able to actually just do regular joins to your Hadoop and SQL Azure blob data using SQL and the relational data that's provided. So Polybase support built into SQL Server now. JSON support. So what is JSON? It stands for JavaScript Object Notation. But what it really is, it's a programming language that your web developers and your mobile web developers know all about. It's good for them putting objects in and out of the database. So what I can mostly relate that to is back when XML was just added as a feature inside SQL Server, where you can actually export data as XML, take XML and easily interpret it back into SQL Server, and even the data types inside can easily store XML. And similar to that, now you can do the same thing with JSON, and your web developers and mobile developers will definitely want to be able to take advantage of that. Another 2016 feature. Okay, Query Store. What is Query Store? So this will help you. This is it actually saves your historical query plans. So what does that mean? Think about this. How many of you have had this issue? So you've had a stable SQL Server for a very long time. You haven't done any updates to it. It's just sat there, run steady, done regular normal growth, worked fine. There's queries that worked perfectly last week, but then now all of a sudden, maybe someone's reporting, hey, when I click on X page, or more specifically, when I run specific query here, it's slow, and I don't know why. It was quick last week, and you know that nothing has changed as far as code or procedures. What do you do? Well, the way it's always been, yes, you can actually open and get the current execution plan and try to figure out why is it slow right now. But in 2016, you actually have what's called the Query Store, and you can actually save your historical query plans, and then you can go back and figure out at what point in time did something change. So there's 3 types of stores built into the Query Store. So first of all, you have a plan store, which actually keeps all of your execution plan information, and then you have your runtime stats store, which keep all of your execution statistics information. And then last but not least, you have your weights stats store, which means that maybe something has changed. Maybe it wasn't, maybe a specific table grew, which caused your query plan to change. Maybe something else changed in your environment, and now you're waiting for reasons that you didn't realize before, and the weight types have changed for these specific queries. So 3 different methods for the query store that you can really do some deep digging and troubleshooting to try to figure out what changed in the environment to cause your stuff to slow down, and definitely will benefit your troubleshooting. I also mentioned briefly under the previous tab with the increased data security and increased encryption, row-level security has been introduced in SQL 2016. Big benefits. Stretch database. So you want to know, what is stretch database? Do you have one of those large databases that maybe you wished that you could take advantage of the cloud now? Everybody talks about the cloud, wishing I could move some of my data to the cloud. Maybe you have that large database that you wish, if I could just take some of my older data, maybe all the stuff that's not actively queried, the stuff that's maybe older than 3 months, put that up in the cloud where I could take advantage of that and only have my active data down here, but I don't really want to have to recode everything or write new procedures or write new application and to be able to do that. It kind of like partitioning. You know, if I could just partition the older data to be up in the cloud and keep my fresh data here current with me, that's what I would love to do. Well, you just basically described stretch database. You can implement the stretch database in the Azure cloud and put in points that you would like for it to reference, and then everything beyond that point gets pushed up to the cloud, and you don't have to change your queries. You don't have to change your application. It just works. And so that's a new feature that's inside 2016 that can let you take advantage of the cloud and basically partition your data without using an actual partition now. Last but not least on this slide, temporal table. So what's a temporal table? It's kind of like having to do a table audit or doing a SQL audit without having to implement triggers. And it's not the same thing as change data capture. So temporal table, you can actually set that up and you can actually query from it and figure out at a point in time what was my table data like. So you know that something changed. It's actually audited, and you can actually tell that these different fields have changed, but you want to know, maybe there was lots of changes, and you want to know, what was my data in this table like yesterday at 12:30 p.m.? You can do that with temporal table now. You can query back almost to a point in time, and it'll tell you this is exactly the way your data was in this table at this point in time. Neat feature, awesome. That's available in SQL 2016, not in 2012 or 2014. All right. So that's choosing which version of SQL Server, and yes, I'm definitely sold on 2016, but let's go to the next slide. Which edition of SQL Server do we need to choose? So do we need to pick SQL Standard or SQL Enterprise Edition, or maybe am I going to get by with one of the Express or Light type editions? Okay, so what I've put together here, yes, there's a link. You can actually see here what is available and the different editions of SQL Server. But I tried to put a little bit of a nutshell here. If you need any of these features that I have listed here, then that means you definitely need Enterprise Edition, not just Standard Edition. So if you need any of the advanced high availability pieces inside SQL Server, such as always on or clustering, well, then you have to have Enterprise Edition. If your server needs more than 24 cores, or maybe it needs more than 128 gigabytes of memory because you have so much crunching to do, well, that will require Enterprise Edition. If you need TDE, the transparent data encryption, some of the higher levels of encryption with SQL Server, that's part of Enterprise Edition, so that's what you'll need. If you need any of those advanced BI features that I gave you on the benefits tab of the presentation, like the in-memory column store, any of those advanced BI pieces, that will require Enterprise Edition also. So next slide, I want to talk about now. Let's see here. The upgrade advisor in SQL 2012 and 2014. The upgrade, we talked about this briefly also, but the upgrade advisor was the tool that's available in the 2012 and 2014 software when you're getting ready to do an upgrade in your environment, and it would actually tell you some, give you advice on your upgrade or give you warnings on your upgrade. I mentioned briefly like you need to update your .NET. Things like that is what the upgrade advisor would do for you. So the downfalls were, of course, if you needed to install on 2012, you could only use the 2012 upgrade advisor. If you needed to install on 2014, you could only use the 2014 upgrade advisor. Also, it was only available for something that was local on your environment. So you couldn't use it for like something in Azure or something in a remote location because it just wasn't designed to be able to do that. Data Migration Assistant is the new upgraded version of Upgrade Advisor, and they've changed it so much that it's basically a new product. It's not just Upgrade Advisor updated, which means that it can actually do migrations for you. It can actually upgrade your data for you, and it can be used in Azure also. So if you need to do that migration to Azure, the Data Migration Assistant can help you with that and actually move the data for you. Another thing is that Data Migration Assistant is also backwards compatible, where the Upgrade Advisor is not. So let's say that your business has decided that you need to go to 2012 or 2014. Yes, the software that you'll have or that you've downloaded or that you've purchased will include an Upgrade Advisor, but I'm telling you that if you're definitely going to do that, I would download, which I've provided the link, the latest version of Data Migration Assistant and use that to help you with going to your 2012 or 2014 environment, not the Upgrade Advisor. It's definitely more robust and definitely can do more for you, and you can actually use the tool to help you move logins, things like that, from your old environment to your new environment. It's one of the things that you can't forget, but this tool can actually help you to do that. So my recommendation is actually downloading and using your Data Migration Assistant, not using the Upgrade Advisor, even if you're upgrading to 2012 or 2014. All right, we're going to talk a little bit about upgrades themselves. So what type of upgrades are there? How do I do an upgrade? The first thing out of the box that we want to mention when you're doing an upgrade is, why not just do an in-place upgrade? It's simple. You know, you put in your software, attach your software somehow, run the wizard, it upgrades your system, done. So yes, it's very simple. All you do is update the existing binaries, and it works. I've done many of them like that. It just depends on your criteria. So also the pros of that, it's definitely less expensive because you don't have an additional hardware you have to purchase for the update. You don't need to migrate your jobs or the logins or the link servers. It's already in there in your master database and in your MSDB database. So it sounds like, well, why not do that? It seems like it would be super simple. Well, you have a very difficult recovery. If you do that in-place upgrade, and once it's done, if you have to roll back for a reason, maybe your applications can't talk to it for some reason, and you make a decision that you have to roll back, well, now you're looking at a complete server restore. So you have to roll everything back to that previous level, and most likely you're going to have to reinstall SQL Server and restore your databases that you have from backup, because you've now put yourself in a really tight situation, and the recovery is very difficult. Also, it's not very likely that the hardware and OS that you have in place on that 2008 server will actually meet the SQL 2016 requirements for 2016. So, which means that you would have had to have done an in-place OS update already with patches, hotfixes, and everything to bring it up to a higher speed in order just to do the in-place upgrade for SQL Server. So it's definitely a big risk. You don't have that comfort level of the recoverability, because it's definitely you'll have a big restore that you have to do if you have to roll backwards. All right, we're going to talk about, a little bit about, I think it double went. All right, we're going to talk about single server upgrades, but on a multiple instance. So let's say on that same single SQL server, you want to still use that same hardware, but maybe you want to go ahead and install SQL 2016 to a separate instance and then migrate between instance A and instance B. So what are the pros of this? Yes, you won't need a second server, but the cons for that same exact thing is that you're going to have double the drive space on the same server. So most likely you're going to have to update your disk space to be able to handle double the hard drives on the same server. And also you have to do the exact same updates, which I mentioned, update the OS, even though you're going to do multiple instances. You're going to have to update your OS, update all your hotfixes on that same server, make sure you have plenty of disk space, and then on top of that, you'll have to change your applications now to point to an instance name instead of most likely the default instance that you had on that old SQL 2008 server. So you're going to have to install everything to an instance, make sure the OS is all updated, and then fail over to the new server, the new instance, I should say. But you still have the original instance as a backup if you had to roll backwards. So you do have some protection there. If something happens and you can't, maybe there's some features that's not working right in your new instance, you can roll back to the original instance and then continue on with your business. So the other thing is, with a same server, multiple instance migration, you can use all of the same migration methods that you would use with a two-server migration, but in between the exact same instance you have there. So what are those methods that you would use to migrate between instance A and instance B, just like a two-server migration? Well, that's what we'll talk about. So a two-server migration, what are the pros of a two-server migration? Well, first of all, you have a potential hardware upgrade at the same time. So it's been, like I said, we're talking about SQL 2008, upgrading to something like 2016. In the last 8, 9, 10 years, there's been definite hardware advances, and you want to try to be able to take advantage of that while you have the opportunity. So now you have a potential of beefing up your hardware to get that performance enrichment. Hopefully you can take advantage of that right now. And also, with that a two-server update, you have the recoverability. It's much easier. You don't have to touch your existing production environment in order to do this upgrade. You can leave it pristine, leave it healthy, and if something happens and you have to roll back and recover, all you do is turn back on that original server. You don't have to do anything to it. Point your apps back to the original server, and it's done. So it's definitely a security blanket. It's definitely helping you to know that if that problem happens, you can roll back, and it's not going to be an issue. Okay, so what are my two-server upgrade methods that we can talk about? Okay, so the very first one that is very common is database mirroring, DB mirroring. So you can actually set up a mirror between your old server and database and the new server and have the same database there. At go live, since the mirroring is in place, all you do is fail over from old server A to new server B, and then the database is there. Sounds easy, and it's not a problem. Now, you can't fail backwards using mirroring, so if there is a reason you have to roll back, and you will be removing the mirroring once you go live, at least you do still have your database on the source server in the condition that it was. There may be some transactions that have occurred on the new server, but if you've rolled backwards, you have to figure out a way to get those transactions back. But both environments still have all their data. You can easily roll back to server A and pick up where you originally left off without having to worry about things. But database mirroring is definitely only a one-way failover in an upgrade scenario. You can't fail backwards using mirroring. Same thing with the next step, log shipping. You can set up log shipping instead of mirroring. It can constantly send over your transaction logs to the new server. And then when you want to go live, all you do is do your database restore the transaction log with recovery, and then bam, your database is live, you're ready to roll. Same thing though, you can't do a restore from a newer version back to an older version. So it still has the same drawback. If you need to get those transactions back to the older environment, you'll still have to figure out a method to do that, but your original environment is still pristine, like I mentioned. So you only have the danger of losing some transactions and having to get those in the other environment, but log shipping is still a very good method. Backup and restore. This is one of the most commonly used tried and true methods. Now, the drawback of backup and restore is the amount of time that it takes. Yes, with DB mirroring and log shipping, you have a very small window that you can have for go live. So if you only have a couple hours of approved downtime to be able to go live on your server, even as little as, let's just say 15 minutes, 30 minutes, you can use something like DB mirroring and log shipping. If you want to do backup and restore, it definitely takes more time. You actually have to back up each of the individual databases, copy them over to the new server, and then manually restore each one. So you don't have the luxury of the small downtime window if you're doing backup and restore. Now, it definitely works. It's not a problem. If you can get the approved downtime, there's no reason you can't do normal backups and restores going from the old server to the new server. Same thing with detach and attach. So you can use SP detach in the old environment, detach the database, copy the files over, and just attach them. The only downtime necessary is the amount of time it takes to actually copy the files over from server A to server B. So I get asked all the time, what's the difference between detaching the databases and taking the database offline? So in your original server, if you want to take the database between server A and server B, you can either detach it, but this actually removes all the records about that database existing from your sys databases. Or you can right-click it and take it offline, which leaves the record of the sys databases on the database, but turns the database off, does a clean shutdown, and then you can still get to the files, the MDF and LDF and NDF files if they're needed, and then copy them over from server A to server B. Now, if you need to fail back to your other server, it's still there in an offline mode. All you have to do is right-click on it and bring it online. Since the record still exists in sys databases, it's right there. You turn it on. So my recommendation is, if you're going to do an attached scenario where you copy it over and attach the database, just take the databases offline on the original server. Don't do an actual detach. Or almost the same thing, you can actually stop your SQL services and then copy the files that way, so you don't have to worry about taking them offline. And then if you had to recover and go back to your original server, just bring your services online. It's basically the same scenario as bringing your database online inside the Management Studio GUI. So that's kind of the difference between detaching a database and taking it offline. All right. The next method that you can actually use is definitely a more intimate method, and maybe there's a specific reason that your business would require this method, but it's not one that I would really prefer. It's using something like SSIS or data export to actually migrate the tables between your original database and the new database. So maybe there's a specific reason you need to do this. Maybe you need to transform your data. But if you were going to do something like this to migrate the data between an old environment and a new environment, you need to have more intimate knowledge of your databases. I recommend using a product such as like the Redgate SQL tools, doing a SQL compare and the data compare, so that way when you're done moving your data between environment A and environment B, you can do some type of comparison to make sure that all your structures are right, all your foreign keys and primary keys are in place like they should be, all your constraints are in place, because a regular transfer won't get that. You'll get the data over, and you'll get maybe those key values in place, but they won't know that they're keys. They won't know, they won't have their proper information that's in there in the schema. So use something like those Redgate tools to do a proper comparison when you're done. Also, what's neat about those tools that I mentioned, any one of those original scenarios like mirroring and log shipping, that SSIS, if you need to roll back, you can use tools like that to compare your data and generate scripts to actually get the data from your now new environment back to the old environment in case you have to fail back. So you can do a comparison, generate scripts to get those transactions back. It's a great tool to use and a great tool to have. I've definitely used it multiple times for things like that. All right, last but not least, and this one's probably the least used, but there's a specific reason why you would probably want to use this two-server method. I call it migrating first and then actually doing an in-place upgrade. So what this means is you have your original SQL Server, and then you've installed your brand new Windows server to actually do the upgrade to. And now what you do is you install SQL just like you have it on your original server. Install the exact same version, exact same hotfixes, so that way the ID inside your AT version inside for the original SQL Server matches what's on the new SQL Server, but you do already have your new hardware in place. You try to configure the drives exactly the same. It makes it easy. You can actually, like I said, there's so many different ways you can do this. But anyway, the easiest way is you have the drives configured exactly the same. So if your databases on the first server are in D SQL data, try to make sure that you have a folder set up appropriately on the second server, D SQL data. So you get SQL set up on the new server, the exact same version. You can stop your SQL services on both, copy over all your databases to the exact same location on the new server, and then make sure your SQL configuration utility is configured to go to point to the master database that you've just copied over. And since you've actually copied over all the user databases to the same locations, it should be able to see every bit of that, and you can start your SQL services on the second server, and it will start up. So yes, there's a couple tricks inside the SQL configuration utility to make sure it's pointing to the proper log folders, you're pointing to the proper master database, but as a rule, you can actually get everything all over with your logins, with all your scheduled tasks, with all your linked servers over to the new hardware without having to do anything much more than that. And then now what happens, you've started up SQL Server, you're on the new OS, you're on with all your new OS hotfixes and ready to roll with the exact same version of SQL Server. Now you can just run your wizard and do your in-place upgrade, so that way you can upgrade to the newer version of SQL Server without having to worry about migrating those linked server connections. Maybe you've got one of those reporting services scheduled tasks that have like 500 scheduled jobs in there, and that was your reason you need to get that over. Well, that's when you go back to this scenario where you copied over like that, then do the in-place upgrade. Now you still have your original server that you can fall back to in case there's a problem. And this method is definitely probably one of the more difficult ones, but there's reasons for it in certain situations. So that's probably the most exaggerated one that you have to do, but it's definitely doable, and I've definitely done that before as well. All right. When you've done a two-server migration, there's definitely some things that you need to think about when you're done. So actually, before you're done, you can actually script out and migrate your logins between server A and server B. It's one of the things you definitely have to do. So it's not going to be incorporated or built into when you do log shipping or mirroring. You have to actually get those logins from server A to server B in place. So I have included links in there to actually help you script out your logins and migrate them over. But definitely what I recommend you doing, though, is like what I told you, use the Data Migration Assistant to get your logins between server A and server B, and that'll actually help you out. Migrating your jobs and tasks, unless you do that last method I was telling you, in the previous slide, if you need to get those jobs over between server A and server B, you have to script out each one, copy them over the scripts, and then apply the scripts and migrate those jobs one at a time. It's difficult if you've got lots of jobs, but it has to be done, and you can do it. But definitely script things out, take note of everything, and apply the scripts on the new server. Replication. If you're doing something like migrating using like the log shipping or the mirroring, I definitely recommend remove the replication from the source server before you fail things over, and then on your destination server, reapply the scripts for your replication and start replication up fresh. Don't try to cheat and copy it over from server A to server B and keep your replication intact. I've seen lots of problems. Only probably 10 to 20% of the time does it actually work. Usually you'll end up having some type of a problem, something will be overlooked. So I truly recommend scripting out your replication, applying those scripts to the destination server, and start replication fresh on the new server. All right, SSIS. This is probably in the same bucket. I should mention SSIS, your encrypted items, and the TDE type encrypted items. If you have your SSIS in a database, you'll have basically probably normally called SSIS DB. If you need to migrate this database or a TDE database, or maybe one that actually has encryption in your application, you need to make sure that you are able to migrate, or that you back up your encryption keys from the source server and apply them to the destination server. So it's not hard to do, but it's a step that's easily overlooked. I did actually provide that in my outline, and there's links there that'll help you script out. If you need to migrate your SSIS DB or a TDE encrypted database, you can use those instructions, but the main thing is you got to make sure you just get the master keys out and any of the user database keys out, asymmetrical keys, copy them over and apply them on the new server. And it's a little bit tricky, but it's definitely a doable thing, and it's something you can do ahead of time also before you do that failover in the migration. Okay. Last but not least, the post-migration requirements. So what are some of the things you need to think about when you're doing this migration also as well? So your database properties, if you've actually detached the database or actually just backed up and restored it, database properties are things that get reset when you attach it to the new server. So maybe you have a CLR objects inside your database. When you apply those to the new server, very likely the trustworthy setting will be turned off, as well as some of the other DB properties. So these are things that you need to make sure you track when you copy over the database from the source to the destination, so you can make sure you put those back. So trustworthy is one of the things you need to think about. Orphan users, this happens all the time. When you take a backup from server A, apply it to server B, many times there's the link, or it can actually orphan a user that's in the database and it's no longer linked up. There's scripts that I've applied in there that I actually have in my outline there that'll help you identify orphan users and help you fix orphan users. Database ownership. If I restore the database, if I don't take special steps, there's a very good chance that the new database owner on your new server will be my Windows ID, or the ID that I logged in with. So normally on most databases, it's normally set to sysadmin, or SA is actually the database owner. Some applications require a specific SQL ID to be the owner. So it's one of the things you need to pay attention to. If you're taking it from the source database, putting it on your destination database, you need to make sure that you know who the original owner was and put it back on the new server. Now, maybe you've actually looked at it and you've discovered that it was an improper Windows login was the owner, maybe a previous DBA. Well, fine, fix it at that point and make sure you put it back to sysadmin, but maybe it's one of those applications, like I mentioned, that has a specific app user. You need to make sure you put that back. Otherwise, maybe your application is going to be broken. Last but definitely not least, rename the server. If you've actually copied from one environment to the other, one database to the other server, there's a high chance most of the requirements for your business is to make this new server the same name as the old server, so that way the applications don't really have to change. So it's easy to do that. You can do a select asterisk from sys servers to find out what's the current name, what I normally use is select add at server. There's definitely scripts that'll help you with this that I've actually supplied also, but you find out what's the name of the server, what name do I need it to be. First, make sure the Windows server is named appropriately. Maybe make sure your IP is set up appropriately and bounce the server. And then check inside SQL to make sure that SQL identifies itself with the name that you want it to. And if it doesn't, you have to do, there's simple syntax. You do a drop server and an add server local, so that way it knows, hey, I'm the new local server name, and this is my name. So it's really not difficult, but it's definitely something that you should do. Also, make sure you rebuild your indexes and update your statistics in the new environment after you've put it in place. Maybe you did the maintenance on the database before you copied everything all over. Well, now you're on a new engine. So when you've actually arrived and you're on the new SQL Server engine, go ahead and rebuild your indexes again, update your statistics, let the new engine do its job and sample the data accordingly, rebuild the indexes the way that it sees fit. It definitely needs to be a step that you take on your new server. Okay, starting to run out of time, but there's one last point that I wanted to mention real quick. If you migrated from one of those old 2008 servers that we talked about, there is a fair chance that you still will have one of those old databases on your 2008 server that maybe is set in 2000 compatibility mode. The danger of this, now that you're migrating from old server to new server, is you need to do a DBCC check DB with data purity. One of the 2000 items was that it could actually have columns outside of the values permitted, and CheckDB did not check that back in 2000. And when you change the compatibility from 2000 to, let's even say 2016, it doesn't default automatically check the first time with data purity. So even though the default for CheckDB is checking with data purity, the first time you need to run it manually because there's like a hidden flag inside there that you need to run, and it'll check your database, CheckDB, with data purity. Okay, guys, I've tried to actually cover everything as much as possible. Hopefully you guys have been able to put together some questions for me.